Everyone, this is going to be a geography series for a KPSC. So what I'm going to do here is in KPSC we have a static portion in paper 1. In that, geography is one of the part, right? If you had seen my first video, you would get to know. So I'll be teaching all the static portion here on YouTube for free of cost, to make sure that everyone has that same level to play in the exam. Some people might not be able to attend the coaching classes because of some financial constraints, but I would like to make sure that from my end that everyone has that same base. So let me explain what will be the plan for the geography series. In geography for KPSC, we have mainly three parts. The first one is Indian geography, then we have a world geography, then we have a Karnataka geography. So for Indian geography for class 11th, we have two books. One is physical geography, and the second one is physical environment. First, we'll complete physical geography, then we will move on to physical environment. And this series can be seen by those people who are at the beginning stage, and the people who have already studied once, they can revise it from this series at 1.25 or 1.5x speed. So now let's start with class 11th physical geography, fundamentals of physical geography. So here you have the index of class 11th fundamentals of physical geography book. Here we'll be starting it from unit 2. Unit 1 we will do once we complete all these 15 lessons, then we'll come to first chapter. Then we will do the origin and evolution of the earth. So today we will be seeing the interior of the earth and distribution of ocean and continents. So it will take at max around 30 minutes for me to complete the chapter called interior of the earth. So stay tuned with me, and I'm sure that you will get to know everything that is given in this book once you listen to this video. So I have made it very crisp and clear. So now let's start with the chapter 3, that is interior of the earth. See, basically in this chapter, interior of the earth, we have mainly 4 parts, okay? What are you supposed to know in this chapter? You should know what is the structure of the earth, first thing. Second thing is, what are the sources to know about the interior of the earth? Then you have two small topics. One is about earthquake and the other one is about volcano. So why they have put this thing chapter in your textbook is, see, in geography we are going to study about our earth, right? So first we have to know what is the interior of the earth. That's the reason they have put it here. So now let's start with the first part, that is structure of the earth. See, say you have a cake, right? Most of us have cut a cake and eaten it, right? So in that, when you cut a cake, you'll be able to see a different layers, right? Say one layer is about a chocolate, one more is about a syrup, and one more is about different things are there, right, in the cake when you see. So in the same way, earth is also having different layers, you could say. So the first one, the innermost layer, so this is the innermost layer, this is known as core, and the next layer is known as mantle, and the uppermost layer on which we live is known as crust. Okay, I hope this one is clear to everyone, right? Our earth is made up of three things. One is crust, another one is mantle, and then we have core. In those three things, again there is a subdivision. In crust you have upper crust and lower crust, and in mantle you have again upper mantle and lower mantle. In core you have a outer core and inner core. So this is the structure of the earth. Now what they have given here extra is till what depth, say you are standing on a earth. Let me draw it here. Say this is a crust, okay, and here you have a water body, okay. So this is, we can say this is the whole thing itself is a crust, okay. In crust you have again two things. One is continental crust and another one is oceanic crust, okay. Oceanic crust. Oceanic crust is a place on which water is present. This is the water, right? So here water is present. So this layer is known as oceanic crust. This is known as continental crust because continent is present on this place, right? This is the place where we live. So it's known as continental crust, okay. So now this is how a crust is, okay. Crust extends till 34 kilometer. That's what they have written here, the number 34 kilometers means, see, you're standing here, say you're on the continental crust and you start digging and you go till here. This is 34 kilometer. If you apply a common sense, you can see that if you are standing on a ocean basin and start digging here, this won't be 34 kilometer, right? Because this is a less, the depth is very less here. So this oceanic crust is thin. So can we say that oceanic crust is thinner and continental crust is thicker, right? So I hope this is clear. Now you got to know, right, why is continental crust thicker and oceanic crust is thinner. So this might be one of the questions where they ask which crust is thicker, continental crust or oceanic crust, right? So here you can frame one MCQs, and the depth is 34 kilometer. I hope now the crust part is clear to everyone, right? And one more thing you have to remember is crust is in a solid form. So let me write here, crust is solid, okay. Next let's move to mantle. Let me take a different color pen so that it's easy to differentiate things. This is a mantle part, okay. This whole thing is a mantle and this thing over here is a crust. And let me draw the core one. This whole thing is a core, okay. Now let's see about a mantle. In mantle again you have upper mantle and lower mantle. Upper mantle is from 34 kilometer to 700 kilometer. Lower mantle extends from 700 kilometer to 2900 kilometer. This one I have given it in a more brief way here. You can see this is the mantle, so we can write it here from just a minute. Yeah, 34 kilometer to 2900 kilometer. This one we can say this is the whole mantle thing, okay. This whole thing is mantle. In that again we have two parts as we have seen here. One is upper mantle, the other one is lower mantle, okay. Next let's move to core. In core extends from 2900 kilometer to 6000 kilometer. In core also we have two things. One is outer core, the other one is inner core, right? So this is all about core and it extends till 6000 kilometer, okay. I hope this is clear with the structure of the earth. Here the extra things that you're supposed to know is what is lithosphere, what is asthenosphere. See, Lithosphere is very simple. Let me write it here. Lithosphere. It is what? It is a combination of crust plus uppermost mantle. It's not upper mantle, it's uppermost mantle. Okay, uppermost mantle. Lithosphere extends from 0 to 100 kilometer. Okay, so don't get confused with the whole upper mantle. Upper mantle is till 700 kilometer, but crust is uppermost mantle. Let me show it here. It's because it's good to see. See here, this whatever I'm marking in the black, that will be a lithosphere. Okay, so it is uppermost mantle. Always remember, they can ask you what is a lithosphere. It's a uppermost mantle or just upper mantle. It's a uppermost mantle. Okay, then next let's study about one more word which we hear often, that is asthenosphere. What is asthenosphere? It is upper mantle. I hope now it is getting clear. It is from 100 kilometer to 700 kilometer. Okay, and it is in semi solid state. Okay, this is very important thing also to know. Lithosphere is in solid state, asthenosphere is in semi solid state. See, this is the upper mantle. Okay, so we can say it. Let me change the color. See, this is the upper mantle portion, so we can say this as asthenosphere, the one in the yellow. Okay, this is the asthenosphere. Now I think we are clear with lithosphere, we are clear with asthenosphere, we are clear what is the meaning, like what till what the crust is extends. In crust we have again a continental crust, oceanic crust, that also clear. Mantle is clear, core is also clear. So now let's see one more important thing in the same topic, that is structure of the earth. See, just a minute, let me draw it again for you. Can you see these lines over here? These lines are known as discontinuity. Okay, so it differentiates from one part to the other, like upper core is differentiated from lower core, sorry, upper crust is differentiated from lower crust by this line. So this is known as discontinuity. These discontinuities are given different names. I remember it as a mnemonic or something, you can say CMRGL. Okay, CMRGL. What does C? They have given this name on the basis of the person who found out them. Okay, C represents Conrad discontinuity. Just a minute, let me check if I have put that picture over here. No, I have not put it. I will just explain it here itself. M represents Moho. Then R represents Repeti. Repeti is a name of a person who found this, we could say it's named on the basis of this person because he is the one who gave this to us, this particular differentiation. So we call it by his name. Okay, that's it. Nothing much in this. So G represents Gutenberg discontinuity. L represents layman discontinuity. These are known as discontinuity. I hope this discontinuity thing is also clear to you now. So this is all about the structure of the earth. So if you want to quickly revise it, let's revise it in a quick possible way. So structure of the earth, we are mainly supposed to remember the crust, mantle, core, then lithosphere, then asthenosphere, continental crust, oceanic crust. Which is thicker? Yes, you are right. Oceanic crust is thinner and continental crust is thicker. Okay, and anything else? Just a minute. Yeah, this one is one more important thing. They will ask this type of questions also. So we will see what are those questions, like what is continental crust made of? Continental crust is made up of silicon and aluminum, and oceanic crust is made up of silicon and magnesium. I remember it this way, like see, it's not a true, it's just a saying, like girls cry a lot compared to boys, like boys don't cry much. So Seema is a name of girl, right? So ocean means what? Water. So Seema, water. Okay, so you have to you can remember it that way, it's just the way I remember it. Then for continental crust, it is silicon and aluminum. Mantle is made up of Seema, that is silicon and magnesium, and core is made up of nickel and ferrous. This thing is given in your class 6 geography. So what I'm telling is, see, if you see this series, you don't have to worry about left out of anything, because I am making sure that I cover all the possible things in this whole series. Okay, so you can just study without any worries if we are going to cover everything or not, because I'm going to cover that, you can trust me. So now let's come back to the topic, that is structure of the earth. So now we are done with the structure of the earth. Next, let's move to the second topic, that is direct and indirect sources. So what are the sources from which you can know about the interior of the earth? See, in home also, right? If we want to know something about someone, there are some people from where, there are some sources from where we get to know about things. So in the same way, if you want to know about the interior of the earth, what are the sources? There are some direct sources, some indirect sources. What do you mean by direct sources? Direct sources are those sources which you can see and which you can see and touch. That's the direct sources. Indirect sources are those sources which are not from the interior of the earth. They, we predict them, or we have found something similar to the interior of the earth. They're not directly found from the interior of the earth. Those are known as indirect sources. Okay, let's study about them now. So in direct sources, you have two things. One is volcanic eruption. The second one is drilling. Volcanic eruption means what happens, say there is a volcano here, the all the materials which are inside the earth, they come out, right? That's when you get to know that what is inside the earth. That's when you can study about the interior of the earth. So that is one way, that is volcanic eruption. The second one is drilling. So say you are here on a continental crust and you start drilling the earth, so you get to know what is inside the earth. So that is another way of direct sources. In indirect sources, we have different things like temperature and pressure rate of change, gravity anomaly, seismic wave, meteors. See, seismic waves we are not going to study here. Seismic waves we will study in the topic earthquake, because we will study it from basics in that topic. Okay, now we will study about temperature and pressure rate of change. So what happens is, let me draw some here for you. Say you are here, as you go inside the earth, this is a crust, this is the water body, oceanic crust, and this is the crust. Okay, as you go deep inside the earth, the temperature and pressure changes. Temperature increases in interior of earth due to radioactive elements. For every 32 meter there is 1 degree Celsius rise in temperature. Okay, and they may ask you this question, like temperature increases in interior of the earth due to what? The answer is radioactive elements, because lot of radioactive elements are present in the earth, because of which temperature increases. In the same way, pressure also increases as you go deep inside the earth. And then, as we all know, there's a gravity, right? Gravity also changes as we go inside the earth. And there is one more term here called gravity anomaly. What does gravity anomaly means? Let's see here. Let's draw here other person. See, say this person assumes that the gravity at this point G is say x value. Okay, he assumes that here, okay, G is x. He assumes, but when he goes inside the earth at this point, he gets to know gravity here is x1. So there is some difference, right? X is some other value, x1 is some other value. So x minus x1, there is something, some difference. The difference is known as gravity anomaly. It's as simple as that, okay? The difference in what you calculate and the difference what you actually have, that's the gravity anomaly. So we are done with gravity anomaly. Seismic waves we will see, as I said, we will see it in earthquakes here. Then next we have meteors. Meteors are the rocky solid substance which enter the atmosphere of the earth. We will study more about meteors in our science and tech lectures. So just get to know that meteors are like a solid rocky substance that enter the atmosphere of the earth from the space. That's more than sufficient to know here about meteors. Okay, now let's quickly revise about the direct and indirect sources. Also, direct sources which we get directly from the interior of the earth. Indirect sources are those sources which we don't get directly from the interior of the earth, but we get those things from some other place which are more or less similar to the structure of the earth, like meteors, or it's on the basis of our assumptions. Those are indirect sources. Okay, I hope now direct and indirect sources topic is also clear to us. Let's mark what all we have completed. We have completed structure of the earth, direct and indirect sources of the earth. Okay, now let's move to an important topic, that is earthquake. Most of the people find earthquake and volcano topic to be difficult because we are not clear with our basics. So what I am going to do is, I am first about the basics, and then once we are clear with our basics, then we will go to the depth of earthquake and volcano. Okay, so now let's start with earthquakes. So see, let me take a new place here to explain the things. Okay, it's already there here. Nice. See, this is a earth. Okay, consider this as a earth. Whenever there is an earthquake, what happens? The earth shakes, right? That's what we call as earthquake. So why does the earth shakes? Like, why does the things move on the surface of the earth? Because there is release of some energy from the interior of the earth. The point from where the energy is released is known as focus. Here I have written it. See, consider this as a earth. From the point where the energy is released is known as focus. Focus is also known as hypocenter. You have to remember this because they can ask focus is also known by different names. They can give one option as hypocenter, the other option as epicenter, and two more other options. People usually get confused between epicenter and hypocenter. See, focus is also known as hypocenter, and the place where you feel the earthquake, the shortest distance from focus to the surface of the earth, is known as epicenter. So this epicenter is a point on the surface of the earth and focus is a point in the interior of the earth. So that's the difference. Okay, and one more thing you can remember, this is, see, epicenter on surface of the earth, E and E. So it's easy to remember, you don't get confused. Okay, so focus is also known as hypocenter. It's in the interior of the earth. Epicenter is a point on the surface of the earth where the waves of earthquake are first felt. Okay, now let's go back here. Now we are clear with those two words. So let's see what are the different types of waves. Okay, waves means what? See, say you throw a stone in a pond, there is a movement of water, right? So what is it? It's a wave. So in the same way, when energy is released, there is a moment in the interior of the earth, and that reaches on the surface, that's when we feel volcano. So in the same way, there is a wave released, waves are formed when there is a earthquake. Okay, there are two types of waves. One is body wave, the other one is surface wave. What in body waves, again we have two types, one is P wave and S wave. Okay, so now first we will study what is the difference between body wave and surface wave. Body waves are those waves which are in the body of the earth. Say, I have said you right, this is, just let me change the color of a pen. See, this is the body of the earth. Okay, so the waves which are in the body of the earth are not body waves, and the waves which, see, you're standing here. Okay, so the waves that we feel on the surface of the earth, those are known as surface waves. I hope now you are clear with what is body waves, what is surface waves. Okay, in body waves there are again two types of waves. One is P waves and one more is S waves. P waves means primary waves, S waves means secondary waves. So now let's see what is the difference between these two waves. See, primary waves, they reach faster, and secondary waves, they reach slower on the surface of the earth. So let me explain it to you this way. Okay, just a minute. See, this is the earth, and here you have seen a body waves, right? Now there can be, body waves can be two types, one is primary wave, one is secondary waves, right? These primary waves, they travel parallel about the primary waves and secondary waves, right? So see, in primary waves what happens is, just a minute. Yeah, so in primary waves what happens is, say this is a direction of a wave is moving in this way, you see, that time what happens is the particle will be also moving parallel to the direction of the wave propagation. Let's represent particle with a yellow color. So particle is moving this way, and the black color represents a wave. So wave is moving in, just a minute, yeah, wave is moving in this way, and the particle, the yellow color is a particle, it also moves parallel to direction of wave. And in secondary waves what happens is, the main difference is, see, of the particle which is in yellow color moves perpendicular to the direction of wave propagation. The one in the black represents the direction of wave. So see, the wave is moving in this direction, but the particle is moving in perpendicular direction to that of a propagation of wave. So when you see this type of waves, particle moving perpendicular to the direction of waves, you should say it as secondary waves. And when you see a particle moving parallel to the direction of wave, then we say it as primary waves. That's the main difference between primary waves and secondary waves. And there are some other differences which can be asked in your exam, so let's see them quickly. So primary waves, they are longitudinal waves or mechanical waves. Secondary waves are known as transverse waves. Longitudinal waves, because see, they travel in this way, and here secondary waves are known as transverse wave because they transverse, like they travel perpendicular, they travel like a light wave, so they are like a transverse wave. Okay, not like a transverse wave, they are a transverse wave. And since they travel in a zigzag somewhat like a curvy manner, they travel they reach slower, and these primary waves reach faster because they travel in a straight line, we could say. And primary waves are, they travel through liquid, solid and gas, but secondary waves travel only through solid. Okay, so you can remember it this way: solid, yes, and secondary waves, yes. So yes only. Okay, so this is the main difference between the body waves. Okay, now let's see what are the surface waves. In surface waves, there is only one type of wave, that is L waves. These are the most destructive waves. So let me explain it here. See, say there is a point from where this waves start coming, and the point where they reach the surface is known as surface waves. So of course when they reach a surface, there are buildings, homes, people living, so many things, right? That's the reason when they hit on the surface, they are going to be cause more destructive. That's the reason they are known as most destructive waves. Okay, so now we are done with waves, right? Next, let's see the diagrammatic way of how the primary waves and secondary waves travel. So this is a diagram. The first one is a diagram of primary waves. So see, this is a point from where the energy started to release. This is the point, and it travels. Okay, see, one thing you have seen here is, just see the difference in primary waves, and this is the secondary waves. In primary waves it reaches the opposite end as well, but in secondary waves it starts here and it stops till 105 degree. It does not reach the opposite end because the core in between, it does not travel through that way, because secondary waves travel only through solid. It does not travel through liquid or gas. That's the reason it just travels till 105 degrees. And primary waves does not travel this black area, whatever you could see. This is known as shadow zone. Shadow zone is a place where the waves cannot be detected. That those areas are known as shadow zones. Okay, so this is the diagrammatic way how the primary waves, P waves, and secondary waves, S waves, make a shadow zone, and till what degree they travel. Say it's 105 degree here, and here it is from 105 degree, and from 105 degree to 145 degree they are not detected. Again from 145 degree they are detected for primary waves. Okay, so this is primary waves, this is secondary waves. So this is clear, I guess so, right? Next, let's see one of the important ways to measure these waves. That's very important. See, there is a earthquake at place. Say this is a earth, this is a place, say X, and we felt there was a earthquake at this place. Say there was a person standing here who felt that there was a earthquake over this place. So how do you measure what was the intensity of the earthquake, what is the magnitude of an earthquake? For that, see, in home, right, if we want to measure something, we use a scale. In cloth shop they use a scale to measure how many meters of cloth do you need. In the same way, is there any instrument which could measure what was the magnitude, what was the intensity of the earthquake? Yes, we have an instrument to measure the magnitude of an earthquake. We have a Richter scale, and to measure the intensity of an earthquake we have Mercalli scale. Okay, how do I remember is, see, every mother want their children to see rich, right? So they want their children to be seen as rich, successful, independent in their life, right? So magnitude, rich. Okay, that's how I remember. And for Mercalli, the other one is intensity, and even it ends with Mercalli ends with I, right? So it's used to measure the intensity. That's how I remember it. These are the two scales which is used to measure magnitude and intensity of earthquake. And there is a graph also. We draw a graph of how the earthquake has, with what intensity it has traveled. Say there is like this in hospitals we have seen, right, like there is a heartbeat graph which is going, right? So in the same way, how did the earthquake, with what intensity did it travel? To know about those things, we draw a graph. That graph is known as seismograph. That's the, yeah. And one more thing we have about the earthquake, there are different types of earthquakes. So I remember it by a mnemonic called as RVCET. Even you can remember it. So what does RV is a college, right, in Bangalore, and to pass the, to get a admission into that college, what do we write? CET is the exam. So it's just RVCET. You can remember it that way, or you can just remember it in a whatever way you wish to. So see, what does R represent? Reservoir earthquake. V represent volcanic earthquake, C represent collapse earthquake, E represents explosion earthquake, T represents tectonic earthquakes. These are the different types of earthquakes which can be seen. Okay, so let's see in detail about each one of them in short. See, what does reservoir earthquake means? See, there is a dam, okay, at a place X, say there is a dam. So there is a reservoir, right? So if any earthquake which happens near the reservoir, that's called as reservoir earthquake. Volcanic earthquake is what? Say there is a volcano, okay, and the earthquake happening there due to this volcano, that's known as volcanic earthquake. Then we have the other three: collapse earthquake, explosion earthquake, and tectonic earthquake. So collapse earthquake, we could say it like, in the mining area, right, they dig a land. So whenever they are digging, there is an earthquake due to mining, and it collapses. So that's a collapse earthquake. Then explosion earthquake and tectonic earthquake. You need not have to go in depth much about it because they're not asking many questions from here. So that's about the earthquake. Now we have completed earthquake as well. Okay, right? Let's move to the last topic of this chapter, that is volcanoes. So volcanoes are of again 5 types. I remember it by a mnemonic MSCFC. Okay, so mid oceanic ridge volcano, shield volcano, caldera volcano, flood basalt volcano, composite volcano. Before going in depth about these volcanoes, let's understand the basics of volcanoes. Like what happens when the volcano is there? Like when you see a volcano, what does you see? There is a lava coming out from a volcano, right? So there are basically two types of lava. Lava is what? The liquid one you see, that is the lava, right? When that liquid part comes on the surface of the earth, like outside earth, that is known as lava. When it is inside earth, say there is a earth here, and here you have the, let me change the color of a pen, red, because it's the lava is usually red, right? So this is a lava, sorry, this is a, when it is inside the earth, this is known as magma. And when it comes to the surface of the earth, this is known as, the same thing is known as lava. When it's inside the surface of the earth, it's known as magma. Okay, now let's see what are the different types of this lava. Lava is basically of two types. One is basic, one is acidic. Okay, so basic means what? See, what, how do you differentiate the basic lava from acidic lava? There are mainly 2-3 things. First one is silica content. The next one is the flow of the lava, and viscosity, we can say. Viscous means how easily can it move. Say water, when you pour, it can easily move, but when you put a solid, does it move? No, because it's not viscous. The flow, with how much easily it can move, is if it is able to move easily, or is it not able to move easily. That's what we can say viscous. On that basis we decide the viscosity of a material. Okay, so here also let's write it's silica, flow, viscous. In acidic lava, silica content is more, flow is less, since because it's more viscous. If the material is viscous, then the flow reduces. Say example, honey. Okay, since honey is more viscous, it does not flow easily, right? Water is less viscous, so it flows easily. So it's opposite, acidic opposite is basic. So silica content is less here, flow is more, and this is less viscous. Excuse me, yeah, sorry for that. So see, they can ask you in exam, basic lava is viscous or less viscous or more viscous? It's less viscous. Basic lava has less silica content or more silica content? It has less silica content. This is like very important that you should know what is the difference between basic lava and acidic lava. And due to these things, there are different types of stones which will be formed, which we will study in the chapter rocks and minerals. Okay, so that's what is the basic about a lava. Now let's see the different types of volcanoes. Since now you are clear with basic lava and acidic lava, you could see here that shield volcano is basic in nature. That means it can just flow. When there is a burst of a volcano, then it just starts flowing this way. If it is acidic, then it does not flow, it just stops there itself, and it turns into a solid form. So the basic lava are, one is shield volcano and flood basalt volcano. Flood basalt volcano, this one is, you could see in the Maharashtra plain. Maharashtra plain is formed due to flood basalt volcano, because it has spread so much, because it's a basic lava, it has spread over a huge region. That's the reason we call it as a basic lava. Okay, so the other three things are mid-oceanic ridge volcano, caldera volcano, and a composite volcano. You need not go into much deep about these volcanoes, like how does these volcanoes are formed. You just sufficient to know that basic lava, acidic lava, the types of volcanoes. Okay, and since these things are formed when the lava that flows out on the surface of the earth, say this is a earth. Okay, when the lava is trying to escape to the surface of the earth, but in middle itself it solidifies. So those things are known as intrusive forms of volcanoes. Okay, so in intrusive forms you have again different types. The one is sill, then you have phacolith, then you have dike, batholith, lopolith, and lacolith. Okay, let me draw it here to show in simple way, like the structure of the intrusive forms of volcano. Okay, see here, consider this as the earth. It's the lava is trying to come out from here, but due to some reasons it's solidified here. It can be formed in a sheet form. Say it is sheet is formed, or phacolith means it's in this way, S shape. Sorry for the drawing, it's in the S shape, like you throw a ball, right, it forms a S shape. That's a phacolith. Just a minute, I will correct that thing. Yeah, this is a phacolith. And then you have a dike. Dike is in this perpendicular shape. If you see any intrusive form of volcano, that is known as dike. Then batholith. Batholith is like a bed of lava is here, like a bed of lava which solidified here. It's not a bed of lava, it's like a lava which solidified on a place is called as a batholith. Then you have a lopolith. Lopolith is in this saucer shape, this way. Lopolith is like this C. Okay, the inverted moon, you can say. Yeah, the inverted half moon shape is lopolith. Then you have lacolith. Lacolith is in this mushroom shape. Just a minute, I'll extend it here. So it is like this in the mushroom shape, you could say. That is known as lacolith. So these are the main 5 to 6 type of intrusive forms. You need not know much in depth with this, just know that these are the intrusive forms, and like they are formed when the lava is solidified in the interior of the earth. So yeah, that's it about the volcanoes. Now let's see. Yeah, we are done with volcanoes as well, so we are done with interior of the earth. In the next class we'll be studying the next chapter, that is distribution of ocean and continents. Okay, thank you, have a good day.